The fish is 14.8. After 1 year old, if it's 3.7 inches long, it still has 11.1 inches that it could grow, right? That together adds up to 14.8. We're going to leave this third column blank for now because we're going to use a formula and see how close the formula gets to our, this is just like an actual fish that they studied. And then this is going to be our scientific formula over here. So for each of these rows, excuse me, you're just going to take 14.8 and subtract the current length of the fish. So I'm just going to subtract like 7.5. So I have 7.3 inches left to grow. All right, so if you could fill in that column just by subtracting from 14.8 each time, and we'll do that for a minute, and then I'll show you what we're going to graph. So I've circled the two columns that they want us to graph. So we're going to graph using a scatter plot on our calculators and come up with a formula, an exponential formula that relates remaining growth, that R column, to age. So to plug that, we're doing the Fishy Regression page. So to do that, you go under Stat Edit. So you might not remember where it is. So it's under Stat Edit. We need to enter these two columns in our graphing calculator. So you go to Stat Edit. And you're going to put this in list 1 and this in list 2. We generated this list, those of you that just came back, by basically taking the total length 14.8 and subtracting the current length of the fish. So if this fish is 3.7 inches long, it can still grow 11.1 inches more in its lifetime. And to clear out a list, if you just arrow up and highlight like list 1, if you hit clear enter, it'll clear out that whole list for you. So get your data put into your two lists, list 1 and list 2. You're put data in the calculator, so stat edit. You got it? Oh, okay. Go to stat. I think you went to table. Stat, enter for edit. That's it. You have a calculator in here. Oh, okay, great. You got it? So stat. You got it? Stat edit. Great. To clear, you would hit clear enter right now. And you probably want to do that in the other column. You good? All right, I'm going to put the directions up to view a scatter plot. You're going to hit the second key and then y equals, and you're going to turn your stat plot on. Then you're going to hit zoom 9 to view the graph. No, just the first one, because you only want one set of data. So you go to second y equals, we're going to turn the first stat plot on, and then go to zoom 9. So that looks like an exponential decreasing function, like 1/2 to the x or 1/3 to the x. Is everyone able to get it to show up? It's a little bit tricky if you haven't done the board rate. All right, so I can see that it's an exponential. You got it? Huh? The scatter plot, so you're going to go to zoom 9. Zoom it there. And then that'll give you your graph. Oh, there. You must have entered this data instead of this data. You can leave that in actually, because you're going to that data in a minute anyway. So just go to stat edit and go to list 3 and put this other data in list 3. And then I can show you how to view list 3. All right, so we got our scatter plot. We want to calculate the regression for this exponential function. So that's under stat, calculate, regression. We want it to be exponential. I think that's choice 0. So what you want to do is when you go to second stat plot, you want it to say list 1 and list 3 right there. So that's under, you have to hit the second key and then the number 3 to change that to L3. I'm just talking to Emily. So you're going to go to stat calculate, and I want to scroll all the way down to, see how 0 is exponential regression? So stat calculate choice 0 exponential regression. So I'm on question 2 on that Fishy regression page. Find an exponential function. Here we go. Do I want list 1 and list 2? Yes, I do. Emily, you want list 1 and list 3 right there. All right, and we're just going to go down to calculate it. So it equals 19.11 times 0.63 to the x power. I rounded, but so 19.11 times 0.63 to the x power. So that relates the remaining growth to age. And that is roughly this graph. If I put it in the y equals menu, what was it? 19.11 times point. You don't have to graph this, but see how close it got. So the graph is the graph of that data. So that appears exponential. So what they want you to do, what they'd really like, is they want to know how old the fish is when they pull it out of the water. So they really want a function that relates age to the current length of the fish. So what they want you to graph on the back page, we're going to skip graphing it by hand, just for the interest of time. See question 3, graph L versus T on the back page. Let's just do that on our calculator. So this time, you're going to change your list 1 and your list 2 to this set of data. So go back to your stat edit and change list 2 to the length of the fish now. So 3.7, 7.5, 10, 11.5, oops, did I get this one? 12.7, 13.5, 14, and 14.4. So we're putting these 2 data points in, and when you go to zoom 9, I put my function in the y equals menu just so you could see it. You don't need to have that in there. See how this data is now a different shape? It doesn't look like an exponential function anymore, does it? So the reason that in mathematics or science you would use the remaining growth to get your exponential function is because that did look exponential. This is actually a transformation of that set of data. Can you tell me what type of transformation has occurred? Yeah. Flip over the x-axis. Very good. What would I do in my y equals menu to flip this over the x-axis? Okay, put a negative in front. So second insert, you don't have to do anything right now, but I'm going to change my window because now you're not going to be able to see where the graph just went. So I want to show you this. So there's my data. There's my current equation. You told me to flip it over the x-axis, so I did. What's the second transformation that had to occur to this function? The blue graph is the current function. I want it to the dot, dot, dots. I have to transform it up. Guess how much it transforms up? It transforms up to the asymptote. What's the maximum length of the fish? So when you transform it up 14.8, and flip it over, you get a perfect model for if you pull a fish out of the water, it'll tell you how old the fish is. So here is what I want you to write down for number 4, and then you're going to be able to answer the rest of the questions by yourself. The formula is y equals negative 19.11 times 0.63 to the x plus 14.8. So it's basically this function up here that's been flipped over the x-axis and transformed up 14.8. So now you can finish 5, 6, and 7. You don't have to do the graph at all. So you're going to have to add the predicted lengths to your table. So put this in the y equals menu and figure out the length here. So you could just plug in 1. Like you could plug in 1, see what you get. Plug in 2, see what you get. So you're going to finish, I'm going to cross out the graph. You're going to do 5, 6, and 7. So you have about 5 minutes left for today. So do what you can, and we might have to start with it next time just to finish it up. So I'll make a note that on Monday we'll revisit Fishy Regression 317. People need to finish 5, 7, and 8 and check it off. All right.